Hello.
Yeah, Anshul, good evening, Dr. Vijender from YourPedia.
Good evening, sir. Good evening.
अच्छा अंशुल, आपने फॉर्म भरा था गूगल फॉर्म मॉक इंटरव्यू के लिए, तो कैन वी गो फॉर द मॉक इंटरव्यू विद यू?
Yes, sir. Yes, sir. I'm ready for it.
ओके अंशुल, व्हाट इज योर ब्रांच?
I belong from mechanical engineering, sir.
So can you please tell me your favorite subjects, Anshul?
Sir, I've prepared strength of material, FM and thermo.
Strength of material, FM and
Thermodynamics.
thermo. You know, these are the three basic subjects of engineering, mechanical engineering, and the core subjects of mechanical engineering. So with me,
Yes, sir.
with me, Jagdish sir is also in the panel for the interview.
Okay, sir, okay. Good evening, sir. Good evening.
Okay. So Anshul, can I start now with the strength of material, let us say?
Yes, sir. Yes, I'm ready for it.
Okay. So can you tell me the relevance of Mohr circle? क्यों draw करते हैं Mohr circle?
I've spelled the relevance of Mohr circle. That's right, na?
Yeah.
So whenever in any element of let's say there is a machine and there are a number of forces acting on that machine element. So Mohr circle helps us to analyze the principal stresses at any angle. As we know, stress is equal to force upon area, but the beauty of stress is that if we change the angle, if we change the plane, then the value of stress changes according to the plane. So Mohr circle is a graphical representation where we can find numerous stresses with the help of graph by changing its angle. Else we'll have to calculate it manually. But once we draw the Mohr circle, we'll be able to calculate Mohr circle with the help of graphs here, and Mohr circle helps us to do so.
Why do we want to calculate stresses induced in a body? Why do we calculate stresses induced in a body?
Sir, as the designing of engineering elements goes like this, we first of all find out principal stresses. If it is a brittle material, then we find out principal stresses, and by doing testing on the UTM machine, we have found that what is the maximum stress which the material can handle. So by finding out principal stresses and by calculating the maximum stress which the material can handle, we can equate it and we can find out what is the degree of safeness we can work in, or actually we can find that whether our machine element is going to fail or not. That's why we find principal stresses. It is the maximum stress which acts on any plane of a machine element.
Okay, Anshul, how do you define failure of the component or material?
Failure of a component of a material. Same, sir. We have already calculated the yield strength of the material by testing it on UTM. Then we can find principal stresses, and by different theories of failure, we can calculate that whether that material is going to fail or not.
Okay. You know, Anshul, I am sending you a stress strain diagram of particular material. I am sending you the stress strain diagram of mild steel, and मैं उसमें कुछ अलग अलग पॉइंट्स आपको दे रहा हूँ. स्ट्रेस स्ट्रेन डायग्राम मैं भेज रहा हूँ आपको ऑन व्हाट्सएप, और उसमें कुछ पॉइंट्स मैंने मार्क कर रखे हैं माइल्ड स्टील के. आप मेरे को बताओगे फेलियर पॉइंट कौन सा है, विच पॉइंट विल बी फेलियर पॉइंट. यू विल गेट द व्हाट्सएप जस्ट नाउ. You see and tell me which point is failure point.
Oh, okay, sir. Okay, sir. You send it. I'll look forward.
Have you got the diagram?
No, sir. I've not got the diagram.
Okay, it's coming. And we have sent you.
Sir, I think in my mobile, if you are calling to someone, then I think the net stops. I suppose that is what the condition is.
So you will not get that, right?
No, sir. I didn't.
Okay, let me rephrase the question. In stress strain diagram of mild steel, there is upper lead, there is a proportionality limit, there is a elastic limit.
Yes, sir.
You have seen the diagram?
Yes, sir, it is getting downloaded, but same thing, sir.
Okay.
Whenever
So there is a
on call,
proportionality limit, there is a elastic limit, there is a upper yield point, lower yield point, there is a ultimate point, there is a fracture point. These are the diagrams,
Yeah.
points on the diagram.
Yes, sir.
आप मेरे को तो फेलियर पॉइंट कौन सा है?
Failure point, sir, we'll have to look with we are working on steel, then failure point will be yield point. Lower yield point will be considered as failure point for steel, sir.
And what is the stress calculated at lower yield point?
What is the usual stress value for steel in you are asking, na?
Where do you calculate yield strength of the material?
Yield strength on which machine are you asking?
I am asking yield strength is calculated at which of the points which are shown on the stress strain diagram?
Okay, yield strength is lower yield strength which we calculate.
Lower yield point, right?
Yeah, sir. We go with the calculation with lower yield point.
Can you tell me the reason? Can you tell me the reason?
The reason is, sir, we can actually go with upper yield point and lower yield point. But the reason behind using lower yield point is that, sir, it is kind of a fixed value which we get usually. When I was doing my internship, I observed that the lower yield point is something which we usually get same, whereas the upper yield point changes from specimen to specimen. That's why mostly we use lower yield point for the calculation.
Okay, can you repeat this answer again? Why at lower yield point do we calculate yield strength?
Sir, I said that when we use the UTM for calculating the yield strength, for upper yield point, there is a change in the value sometimes. Because, for example, 300 is the upper yield point and lower yield point is 500, for example, of a material. Then for the upper yield point, we may get 250 or 350 for the upper yield point. But for the lower yield point, when we calculate on UTM, it's near about same. Every time we get the same value, that's why we go with the lower yield point for calculating the stresses or for finding out whether our material is strong enough to sustain these stresses or not.
Okay, how do you define the strength of a material? What is the meaning of strength?
Strength of the material is a lower yield point is considered as the strength of the material.
Okay, lower yield point, huh?
Yes, sir, lower yield point.
Okay. Can you tell me what is point of contraflexure?
Point of contraflexure on bending moment diagram. No? Sir, when we draw the bending moment diagram, the point at which bending moment becomes zero, that point is known as point of contraflexure.
So what is the relevance of it?
The relevance of it is that at the point of contraflexure, we have highest amount of shear force over there.
Okay.
So, sir, if we want to calculate that whether our material is going to fail in shear force or not, then at the point of contraflexure, the value of shear force is high. So we can take that value from shear force diagram and equate it with our yield point, and we can find that whether or not our material will be safe in shear force or not.
Okay, Anshul, now FL से कुछ क्वेश्चन पूछने वाला हूँ मैं आपसे.
हाँ sir.
So can you define the different forces acting on a fluid element?
Forces acting on a fluid element.
In fluid dynamics, we can say.
Yes, sir. Starting with the very first pressure force, sir.
Okay.
Then force due to gravity. And pressure force and surface tension force.
Okay.
Then after sir, I'm not able to recall it well. But
Okay.
Pressure force, gravity force, and surface tension. There are more. There are around 8 forces, I think.
Yes,
but
yes.
pressure force and gravity force are the major ones.
Okay. No problem. So can you define the different forces that we consider during the Navier's motion, or we can say Navier-Stokes equation?
Sir, these two forces only, pressure force and gravity force.
Okay, pressure force and gravity force. And what are the forces that we consider in Euler's equation or Euler's motion?
In the Euler's motion, no sir, I forgot about it. I'm not sure about it.
Okay, okay. So, have you ever heard about the Bernoulli's equation?
Yes, sir, I know about the Bernoulli equation.
Okay. So, can you basically define the assumptions behind the derivation or basically Bernoulli's equation?
Yes, sir. First assumption is the fluid must be ideal fluid. Then there should not be any we don't consider surface tension forces. Then the fluid is considered to be incompressible. Yeah, ideal force surface, no surface tension, incompressible.
Okay.
Yes, sir. These three assumptions are major one.
Okay. Can you please mention the equation of Newton's law of viscosity simply?
Yes, sir. So according to the Newton's law of viscosity, shear force acting on a fluid element is equals to rate of shear stress. Wait a minute, sir. So shear stress acting on a fluid element is directly proportional to rate of shear stress. And to take out the proportionality sign, we multiply it with viscosity. So shear stress acting on a fluid element is equals to viscosity into rate of shear stress. Sir.
Okay. Actually, I have a question here that shear stress and shear force. मतलब force और stress में what comes first? Force or stress? Which is input, which is output in stress and force?
The force is something which is acting first, and because of that, if there is a resistance in the material, it creates stress. Force acts first, and then stress is created.
In Newton's law of viscosity, mein, what do you calculate first? Shear force, which is also called drag force, or shear stress?
No, sir, I am not sure about it.
Okay.
Okay. Ashur, you define that tau equal to mu du by dy, where mu equal to dynamic viscosity or kinematic viscosity? In Newton's law of viscosity, you defined that tau equal to mu du by dy, where tau is shear stress and du by dy rate of shear strain, and mu equal to dynamic viscosity or kinematic viscosity.
So mu is equal to dynamic viscosity.
Okay. There is one another term in fluid mechanics, that is kinematic viscosity.
Yes, sir.
So why we use two terms, kinematic viscosity and dynamic viscosity?
So
you can say what is the difference?
Yes, sir. Yes, sir. So kinematic viscosity is equals to mu upon rho, which means dynamic viscosity upon density of the material. The reason behind using kinematic viscosity is no, sir, I don't know about it.
Can you tell me the equation which connects thermodynamics with fluid mechanics?
What, sir?
Can you tell me the equation which connects the thermodynamics with fluid mechanics?
Yes, sir. Total energy equation.
Okay.
And that enthalpy on which we use H plus V square upon 2V plus. Yes, that enthalpy equation which we use in thermodynamics. That is.
अच्छा, अगर आपको किसी लेमैन को अंशुल, अगर किसी लेमैन को अपने अवेलेबल एनर्जी एक्सप्लेन करना है कि क्या होता है अवेलेबल एनर्जी, how shall you explain that?
Available energy, sir, according to the thermodynamics law, whatever energy which we are having, for example, there is a reservoir and from which we can extract energy. then we will not be able to utilize complete energy, sir. We'll have to let go some energy to the atmosphere once again. So, for example, we are having 300 kilojoule of energy, then we cannot use complete energy, sir. Because of the concept of entropy, we cannot use 300 completely. So, available energy is that amount of energy which we can use at maximum for running our engine. मीन सर अगर हमारे पास 300 किलोजूल ऑफ एनर्जी है, बिकॉज ऑफ एंट्रोपी हम पूरा यूज नहीं कर पाएंगे, so we'll have to let go some energy, and available energy simply means what is the amount of energy which is available, maximum to maximum.
Okay. Anyway, then Anshul, we give you the feedback of your mock interview here.
Yeah, sir.
Okay. So I start from strength of material, question by question. My first question was relevance of Mohr circle.
Yes, sir.
So answer is, sir, Mohr circle is a graphical method to know the stresses induced in the body.
Yes, sir.
Principal stresses, maximum shear stresses, we can calculate graphically, and that is the relevance of Mohr circle. And
yes, sir.
then the second question related was, why do we even calculate stresses induced in the body? Why do we want to know? Answer is, sir, we
Yes,
want
sir.
to know because maximum stress induced in the body should not exceed its strength. Otherwise, the body will fail.
Yes, sir. Yes, sir.
How do you define failure of the body? Answer is, sir, permanent deformation or yielding defines the failure of the body in engineering.
Okay, sir.
Then I asked you what is strength of material, which you could not answer. You said lower yield point is the strength of material. Actually, strength of the material is the maximum stress which we can induce in the body till failure. Now, failure is you can say failure is lower yield point, but strength can be defined. Ultimate tensile strength is also strength. Failure strength is also strength. Then there are different kind of strength like fatigue strength, etc. So strength means
Yes, sir. Yes.
maximum stress which I can basically introduce in the body.
Okay, sir. Okay.
Then why yield point? I asked you where do you calculate the failure point, which failure point on the stress strain diagram? That you gave very right answer, lower yield point. And when I mentioned why at lower yield point, you gave some answer, though I was not very satisfied. But answer for that can be lower yield point, because corresponding to this, the stress which is corresponding to lower yield point, that is actually the stress at yield elastic limit. Beyond that, the body will go into plastic limit. So if you draw a line from lower yield point to stress axis, it will cross somewhere point lower than elastic limit. So that is the body will remain in elastic limit only if you apply the load so that stress is corresponding to lower yield point. So the body will not be in the plastic range.
Okay, sir. Okay.
So that's the reason lower yield point, and it's a specific point which can be demarcated on the stress strain diagram. Hence, calculated at that point. What is the point of contraflexure? You defined that point of contraflexure is the point where bending moment is 0. That is right answer. But what is the significance that you could not tell? Because understand that shear force is maximum there. But bending equation, if you see the bending equation, in the bending equation, M is the bending moment. And sigma over y, M over I is equal to sigma over y. If M is 0, then the bending stress induced at that point will also be lesser.
Okay, yes, sir.
So their point of contraflexure is the point where bending moment changes its direction.
Yes,
and at that particular point, minimum bending stresses are induced.
Yes, sir. Yeah.
Okay, and the next related question was asked that whether stress comes first or shear force or force comes first. You said force comes first, and before that question was being asked by Jagdish sir, that was Newton's law of viscosity. And in Newton's law of viscosity, first shear stress is calculated, which depends upon the viscosity of the body. And from the shear stress, when I multiply contact area, we get shear force.
Yeah, correct. Yeah.
So in case of solid bodies, you apply force first and then the stress is induced. In case of fluids, viscosity is a property due to which there is a stress induced, and on particular area shear force can be calculated. So the answer has to be different for solids and for fluids.
Okay, sir.
I asked you what is the equation connecting thermodynamics with fluid mechanics. That answer was right. You gave right answer.
Okay,
and then I asked you what is available energy in layman language. So you should you answer which you gave was not very precise. You will say, sir, available energy is the maximum work which I can theoretically extract from the heat energy if I extract it reversibly and if I bring the system to the basically ground state, the dead state, which is called dead state or ground state. So that should be the answer, very precise answer. So from my side, your knowledge is good, but do not bluff like you bluffed in case of point of contraflexure, and as you bluffed in case of I will say Newton's law of viscosity, shear force and stress, and available energy. These were the three questions where you were bluffing. You were not knowing, but still you were bluffing, and that is the wrong. यहाँ पे आपके मार्क्स कटेंगे. कोई क्वेश्चन का आंसर नहीं आता तो आप सिंपली बोल दो, अंशुल मेरे को ये आंसर नहीं आता, लेकिन वहां पे गलत आंसर मत करो.
हाँ सर, सही बोल रहे हैं. मुझे यही प्रॉब्लम है, मुझे नहीं आता तो कॉन्फिडेंस साथ में बोल ही देता हूँ ऐसा जितना ही.
नहीं, ये तुम्हारा नहीं, ये सारे इंडिया का प्रॉब्लम है अंशुल. एक्चुअली स्टूडेंट्स को लगता है कि साहब हमें आंसर करना ही करना है, लेकिन ऐसा नहीं होता. कुछ बॉल्स को आपको बिना खेले छोड़ना है, नहीं तो कैच आउट हो जाओगे.
हाँ सर, सही बोल रहे हैं.
ठीक है, अब जगदीश सर आपको फीडबैक देंगे.
तो अंशुल, जो आपसे फर्स्ट क्वेश्चन मैंने पूछा था, फोर्सेज एक्टिंग ऑन द फ्लूइड, तो उसके बारे में आपको फोर्सेस का नाम पता नहीं था, जबकि आपने बोला था कि मेरा फेवरेट सब्जेक्ट जो फ्लूइड मैकेनिक्स है, और हम फ्लूइड डायनामिक्स की जो शुरुआत करते हैं वही यहीं से करते हैं कि फोर्सेस कौन से एक्ट करते हैं, एंड वहीं से नेवियर-स्टोक्स इक्वेशन निकालते हैं, यूलर्स इक्वेशन निकालते हैं, एंड बर्नौली इक्वेशन की डेरिवेशन करते हैं. ओके, तो इसका आंसर आपने रॉन्ग दिया. ग्रेविटेशनल फोर्स, प्रेशर फोर्स, विस्कस फोर्स, कंप्रेसिबिलिटी फोर्स एंड टर्बुलेंस फोर्स वगैरह एक्ट करती हैं.
हाँ सर, हाँ.
ओके, तो इसको आप याद कर लेना. ओके, नाउ सेकंड जो मैंने क्वेश्चन पूछा था इसी से रिलेटेड, दैट नेवियर-स्टोक्स इक्वेशन में कौन सी फोर्सेस कंसीडर करते हैं, तो उसका भी आंसर आपने गलत दिया. आपने बोला सर प्रेशर फोर्स एंड ग्रेविटेशनल फोर्स, जबकि वो आंसर यूलर्स इक्वेशन का है. नेवियर-स्टोक्स इक्वेशन में
हाँ सर, करेक्ट.
नेवियर-स्टोक्स इक्वेशन में प्रेशर एंड ग्रेविटेशनल फोर्स के साथ विस्कस फोर्स भी होता है.
हाँ सर.
ओके, एंड इसी को हम लोग बेसिकली इसी से डेरिवेशन करते हैं बर्नौली इक्वेशन की.
हाँ सर, करेक्ट.
एंड जो उसके बाद मैंने आपसे क्वेश्चन पूछा था न्यूटन्स लॉ ऑफ विस्कोसिटी का, तो उसको इक्वेशन को तो आपने डिफाइन कर दिया था सही से.
यस सर.
लेकिन उसके बाद जो फोर्स एंड स्ट्रेस का रिलेशन था, जो विजेंद्र सर ने क्वेश्चन पूछा, उसमें आप फिर फंस गए.
हाँ सर, हाँ, वो मुझे पता नहीं था एक्चुअली.
एंड जो अजम्पशन ऑफ बर्नौली इक्वेशन थी, उसमें भी आपने एक अजम्पशन दैट इरोटेशनल फ्लो होना चाहिए, वो भी गलत बताया. बेसिकली आपने बताया ही नहीं.
हाँ सर, वो नहीं बताया.
ओके, तो अजम्पशंस भी नहीं, तो बहुत बेसिक क्वेश्चन थे. एंड लास्ट क्वेश्चन था दैट डायनेमिक विस्कोसिटी एंड काइनेमेटिक विस्कोसिटी का रेलेवेंस क्या है, डिफरेंस क्या है, तो वो भी नहीं आप आंसर कर पाए. आपने सिंपली फॉर्मूला बताया था इसका.
हाँ सर, उसका सिग्निफिकेंस पता नहीं.
तो जितनी भी टर्म्स हैं इसके अंदर, बाउंड्री लेयर चाहे आप पढ़ो, चाहे नॉन डायमेंशनल नंबर्स पढ़ो, कोई लॉ पढ़ते हो, तो उसका फिजिकल सिग्निफिकेंस आपको पता होना चाहिए. कोई टर्म आप पढ़ते हो, और फ्लूइड मैकेनिक्स में आपको बेसिक्स क्लियर करने की जरूरत है, आपके अच्छे नहीं है बेसिक्स.
हाँ सर, सही है.
हाँ.
ओके अंशुल, आपका स्ट्रेंथ ऑफ मटेरियल का नॉलेज ठीक है, लेकिन ब्लफ नहीं करना है. और थर्मोडायनेमिक्स हमने ज्यादा पूछा नहीं, वो नेक्स्ट मॉक में हम कभी आपसे दोबारा डिस्कस करेंगे तो थर्मोडायनेमिक्स पूछेंगे. बाकी इन तीनों सब्जेक्ट्स को अच्छे तरीके से रिवाइज कर लो, और एक YourPedia पे वीडियो भी पड़ा हुआ है 6 घंटे का थर्मोडायनेमिक्स का, उसको सुन भी लेना डिटेल में.
हाँ सर, मैं देखा तो वो ये सर.
हाँ, तो उसको सुन लो, उसमें सारे क्वेश्चन कवर हुए हैं, तो दैट ऑल्सो कैन बी डन. एनीथिंग यू वांट टू आस्क अंशुल?
नो सर, आई जस्ट वांट टू थैंक सर. आपकी वीडियोस के कारण मुझे बहुत सी चीजों के बारे में पता चला जो पता ही नहीं था सर कि ऐसा होता है. मतलब पीएचडी के लिए मार्क्स कम हो तो भी चल जाता है, ये सब के बारे में सर पता ही नहीं था. आपके ही चैनल से पता चला है सर.
चलो, देन यू से द सेम थिंग टू योर फ्रेंड्स आल्सो. थैंक यू अंशुल.
यस सर.
ओके, थैंक यू.
यस सर, थैंक यू सर. थैंक यू सर.